Hey everybody. Today we're talking about regression and prediction. And this is one of the big uses for regression lines, the fact that we can use them to make guesses at the value of a future observation of the response variable for a given value of the explanatory variable. Here's an example. It's a very simple data set with 5 points. I've got the line of best fit here, y equals 0.19x plus 1.34. And I'm thinking about a future observation that has a value of x equals 6 and trying to guess what the y value will be. In this case, I go over to x equals 6 and I go up to the line and I see that the y value there is about 2.6. So this is going to be my estimate for the y value for a new observation with x equals 6. We can be more specific by plugging in the new x value into the regression equation. So I'm taking x equals 6, plugging it in, getting a predicted value of y hat equals about 2.54. So a bit more specific, a tiny bit less than the estimate I got just looking at the graph and doing it visually. For every observation xi, yi in the data set, we get not only a predicted or fitted value, but also a residual, the difference between the actual y value that we observed and the predicted one, y hat, that was given by the regression equation. We use the notation epsilon sub I for the residual of the ith observation. In a plot, the residual is the vertical distance from the regression line to the point, and it'll be positive for values above the regression line, negative for observations below the regression line. For instance, in that same small data set, let's look at the very first observation, 3, 1. When x equals 3, we have a predicted y value of 1.97. And so the residual of that observation is the observed value, the observed y value of 1, minus the predicted value of 1.97. Overall, we get a residual of negative 0.97. Visually, this means that the observation lies 0.97 units below the regression line. Now, a regression line should only be used to make predictions for x values that lie inside the range of the observations that you have. Making predictions outside the range of the sample is called extrapolation, and it's a bad thing. Sometimes you get ridiculous results from that. Oftentimes, you get wrong ones. As an illustration of that, consider age and weight in children under the age of 12. As illustrated here, there's a very linear relationship between those two variables, in the sense that if you know a child's age, you can make a pretty decent guess at their weight by plugging into the regression equation for the line I'm showing here. But obviously, it would be a mistake to use this line to make predictions for the weight of an adult. If we use this regression line to make a prediction for a 40-year-old, we get a predicted weight of over 350 pounds. And of course, in reality, the average weight of 40-year-olds is much lower than that. 350 pounds is a poor prediction for the weight of an unknown 40-year-old.